Hello. Yeah. Hello everyone. Thanks for having me here. So my OpenDaylight project title is Release Dashboard for OpenDaylight project, and it's good. Okay. So coming to myself, I'm SVK Rohit. I'm an undergraduate 4th year. I'm from IIT Hyderabad, India. And my interests are in cloud computing and web development. And my mentor was George. So the project. So what's the goal of the project? Simply put, a dashboard that gives a bird's eye view of all OpenDaylight projects, project statuses. So there are many projects in OpenDaylight. And so this dashboard intends to pinpoint those projects which are lagging behind and specify what specific areas they are lagging behind. For example, a project might not have commits since past few months, or a project might have many pending critical bugs to be solved. So this dashboard intends to point out those. Now how do I point out those, as in how do I calculate those? That is through benchmark analysis of each project. Now what is benchmark analysis is? It intends to give a score to each project based on some benchmark or some criteria. So to evaluate a project, I need data, and to set the criteria also I need data, and I need data from two sources. That is from the tools that OpenDaylight project uses, such as Sonar, Bugzilla, Git, and the results of various performance tests and robot results. So I need a framework where I could mine this data and then store it in a database and then query the database and then analyze it, so that I can calculate the score or do a benchmark analysis. So I have used, coming to technical details, I have used Django and D3 for visualization. The Postgres have used, the database I have used is Postgres, and the tools that I have mined from are Git, Bugzilla, and Sonar. So I have written Python scripts that actually use the APIs provided by GitHub, Sonar, or Bugzilla. They poll it like every 5 minutes, and then they update the data in the database. What is the data? I'll show it in the demo. So for the Jenkins performance results, I had to write a Jenkins post build script which automatically stores the results into the database as soon as the build finishes. A robot listener library for storing robot results. So it's a listener library, so as soon as a robot test ends, it automatically calls the function, and then the function stores the results into the database. So the other part that I have integrated into my dashboard is the OpenStack and OpenDaylight Tempest results that were given by Pramod RJ, the guy from Intel. So by this, one can understand that this dashboard makes it easy to navigate through all types of results that OpenDaylight provides or gives. So the demo. Yeah, so here you can see these are the bugs, the blocker, the confirm bugs, the critical bugs, the number, the count that I have pulled from the Bugzilla API. And this is from the Sonar, the success density, unit test coverage, and from the GitHub last week commits and the total number of commits, and so the number of contributors and the contributors list. So these are the performance results that I have directly pulled from the Jenkins server of all jobs. So it would be easy for the integration team to actually see all the results at one place. And the same with the Boron release also. And these are the Tempest results. Sorry. So this is related to the neutron bound and the OpenStack. So I told you that I have written a robot listener library. So I tested that listener library on a single robot file, and this is the sample information that I have gathered, the job name and the status of it and the build number. The same goes with the performance results, the job name, the plot group, C-bench performance, and the max, min, and average values. So that's it. So the major part of the project that I have did is to actually poll the data, gather the data and store it in a database. The remaining part is to actually visualize this, create a formula out of this. For example, a project that has code coverage less than 50% might be labeled as red or something kind of. So that part is remaining. So it's great to be here in Seattle. These are the photos that I've clicked a few days back. Thank you. So I would like to thank the Linux Foundation and my mentor and Casey, everyone here. Thank you. That's it.
Good afternoon, everyone. I'm Sushant. Last 2 days have been overwhelming with OpenDaylight Summit, and it's been a great experience. Gladly enjoying the summit. Let's move on to the intern project I did during this summer. It was the IoT integration with OpenDaylight and simulator development. So basically, I wrote a simulator to create IoT devices messages. So what I did being an intern here is, so there were some key things that I thought before taking this internship. One of the points was open source isn't just a give, it's a win-win. So I thought let's start working on open source project, and thankfully Colin Dixon came to our university who gave us information about OpenDaylight, and that's where I thought I should be involved in the project. Next thing is software defined network will disrupt is a thing that people say, and it's quite true. And the third point was IoT is a thing where this IoT needs to get integrated with the skill it is being developed. So basically what I did is I created a VM to simulate IoT devices that will actually work with Unified Secure Channel. I'll tell you a little about Unified Secure Channel and how it is integrated with OpenDaylight. And so I wrote that simulator in Java. Basically, this is the USC architecture we can see here. So USC, in USC we have a USC agent, and these are all enterprise edge nodes they are called. These are actual IoT devices. And it communicates with the USC agent, and then USC agent communicates through USC plugin to USC manager the OpenDaylight controller already has. So my goal was to simulate these devices and make this end-to-end connection. So just in a block diagram overview, I would say these are the IoT nodes. There can be multiple of them. So with the simulator, you can simulate one or more number of devices. These all devices are connected with the IoT local server. I implemented with MQTT and AMQP messages. So the goal was to create messages which follow multiple protocols, and then so IoT simulator is the one who is taking care of communicating these messages with the local server. At the top of it, the virtual machine has USC agent, and I clubbed them everything together in an IoT test VM. I developed this using Vagrant. Mr. Anho was my mentor, and he developed all the insights. So this project was actual his idea of testing the secure channel. So this test VM is connected with the secure channel, and on the controller side, it is connected with the USC manager, you can see, and it directly connects with that. I'll just give you a quick demo. So I built up a Vagrant machine here. So Vagrant machine itself, thanks, Casey. So so with this Vagrant up command, it sets up a simulator that runs all the server services at the backend, and then I actually go into this machine. And here you can see IoT simulator. That's the simulator I wrote. So as you can see in the console here, it sends a hello there message to the server, and it just receives a hello there message in reply. So this one particularly is working with MQTT protocol, as mentioned here, and you can also do it with AMQP as well. So that's another ping message that sends to the controller and receives it back. That's about it. The future scope of the same work is to integrate these simulator with the robot framework OpenDaylight already has, and adding multiple protocols to do the same, and finally connecting this to other IoT projects like 1M2M. My key takeaways were background knowledge were very essential. I think open source is better than school courses sometimes, and you have to ask for help for all the OpenDaylight community. Thank you. Lastly, I just would like to thank the Linux Foundation OpenDaylight community, Casey and Anhotu. Thank you so much.
Hi guys. First of all, I'd like to thank the entire Linux Foundation and the OpenDaylight community, and Casey especially. So I just wanted to, give a brief, explanation on how I actually got the internship. So I was already working on, the OpenDaylight platform as an independent project. And while I was working on it, I actually stumbled upon, the whole 2016 summer intern program. And I was doing a project for my capstone project. And I thought that what I was doing, I could extend those applications to the OpenDaylight community and the platform. So just a basic overview of what my project is. It's basically security aspects. So Snort is, the project is integration of Snort with the OpenDaylight platform. And Snort is, it's a tool for intrusion detection. So it's actually a very popular intrusion detection system. And it's a globally accepted security measure as of now for especially the traditional and legacy networks. And when it comes to software-defined networks or any platform like even OpenDaylight, so there was an event, NFV and Carrier SDN at Denver, and the VP of Global Technology Messaging Communications, Ray Watson, he actually stated that we are all screwed. Now, the reason he says that is we are coming up with new solutions almost, every day. So we get problems from the companies and the vendors, and we come up with solutions, with OpenDaylight platform. And the more solutions we create, we're creating that many problems. So sorry about that. So as we are growing, our platform is becoming more vulnerable. So that was one of the main motivations for my project, was to start something that could remotely try to solve the security problem of OpenDaylight. And since we are virtualizing all the network functions, it's difficult to have a perimeter sort of security measure. So that is one of the biggest challenges of the whole software-defined network paradigm. And as we move ahead, as we saw in the summit this time, many companies are adapting to the new controller. I mean, the whole OpenDaylight controller. So they have their own product that is actually based on the OpenDaylight framework, and so there's a very high demand of open source technology like OpenDaylight. And with that demand, people want to make sure that it is a secure solution and not just a solution. So, and about Snort. So Snort was actually it's a very lightweight solution. It's a very lightweight intrusion detection system, and it works in 3 different modes. That is a packet sniffer mode, where it'll scan all the incoming packets, and it's going to identify the malicious activities, and it's going to tell the administrator about it. Then you have the packet logger mode, where it just logs every packet, and which is then the whole report is sent to the admin to correlate all the problems. And then the main is network intrusion detection system, where we actually write a set of rules to identify the malicious activity. So if you have, for example, a DOS attack, so we got to set a rule that if this many packets come in this time, then it could be a potential DOS attack. So that's how that's how Snort is used. So it's a very rule-based signature detecting intrusion system. And I haven't yet sort of integrated both the components, that is Snort and the OpenDaylight platform. But I did have a proposed reference architecture, where what I proposed was, I'm going to mirror all the packets that are coming to the controller to a remote location where you'll have the intrusion detection system working. And once Snort detects some anomalies or malicious activities based on the rules that we have provided, it is then supposed to send out that information to the controller so that the necessary mitigation steps can be taken. And so now I've just thought of Snort, but in future I think we can work to make a common sort of framework so that we can use any third-party tools for as IDS or IPS. So if as of now I'm working on creating a common framework where I can use either Snort or Splunk or any other third-party tools. So it might not solve the whole problem, but we can at least start somewhere, and we can start developing it. So yep, thank you.
I just want to say one thing really quick on the record. He's the only one that did not use one of the mentor-provided projects. He actually submitted his own project, which was approved unanimously by the entire committee that we held to decide what intern projects and what interns got hired. It was unanimously approved that we picked this project because it was so well written. And the fact that he actually took the initiative to come up with his own idea. So maybe just a thought for next year, putting that out there.
Hello everyone, my name is Ashish. Sorry for the delay. And so I am a final year master student from IIIT Hyderabad, and I come to know about OpenDaylight from one of my senior who did an internship last year. And yeah, so my project was titled as JSON generator for robot testing, and my mentors were Lori and Veena. Thanks Lori for helping me throughout the project. And yeah, So the motivation behind my project is, as we all know, that OpenDaylight uses robot test framework for testing. So there are various OpenDaylight services that are running, and for testing them we use robot framework. And these robot framework uses Yang models, which are we uses manually written static JSON files that are stored in Git repository for test. So let's say I have a REST API. So what we do in test, we need to test whether it is working fine or not. So we pass some parameter and get some response. That response is in the form of JSON. So currently what we are doing before this project is those expected JSON files are present in a folder. So we write them manually. Suppose if I want to check the same REST API with different parameter, then what I will do, I'll just create another file with a small parameter change. So this is very tedious task. Nobody would like to do that. So my project, what it did, it automate this process of creating JSON file on the fly. Suppose if I would like to let's say okay, sorry. So as in the most test data that is used in ODL robot test is Yang model. So the second thing that I considered is like suppose I change the Yang model itself. So it is very difficult to debug if what change I have made in the Yang model. Okay, so what I considered is like to debug it, to make the debugging easy, we should use the Yang model itself to generate the JSON file. So that's the motivation behind this project. So our objective was very clear. We need to automate the process of building JSON files for testing by providing some builder-like code that can be called to generate the desired JSON with the default or variable data. So we need a framework that have some that had some helper APIs that can be called in the robot test, so that they can use them in an efficient and readable manner. So and the final deliverable was the migrated test. So before the project we used the JSON files, so we migrated those tests to use our new framework of generating JSON on the fly. So what was our approach? So our approach was first like parse the Yang model itself and capture the syntax, and then generate a Python representation or any high level representation of these models, so that we can fill those representation with some values to create JSON itself, and then use these Python representation to create some Python helper function, so that they can be used by the robot test file itself. And finally, migrate the previously written robot test to use new framework. So that was our approach. So how we implemented it? So there is a tool, open source project, PyangBind. So PyangBind is a plugin for Pyang that generates a Python class hierarchy from a Yang data model, and the resulting classes can be directly interacted within Python. So it's an open source project, and Rob Shakir is like the main developer there, and he's doing a great job in this project. Like also it made a task of parsing the Yang model and then generate the high level representation. Those 2 points are well represented by the PyangBind. So because it helped us in creating Python class from the given Yang models. So during the course of my internship, I found few issues in PyangBind. So it was in a very naive phase. So like PyangBind does not supported bits type in Yang model. Still it is not supporting bits type. So we handle these types separately in our builder code. What we did, like we used some kind of our own logic for the bits. We did it differently. So inheritance of identity values also was not implemented in the PyangBind. So during my internship period, I opened an issue there and also helped the community in providing tests, and they also merged some of it. Also some debugging statements were present in the PyangBind. while generating JSON like underscore underscore yang underscore, and these debugging statements were not very useful for us. Also, it was not like we are here dealing with JSON, so a new field, if it is not matching with the expected JSON, then obviously our test won't pass. So that these kind of statements, I opened an issue for that also, and these are also resolved in the current version. So how we implemented it? So most of my work was based only was integrated in list flow mapping / MSMR robot test on the and integration / test project and relang / builder project. So how I did it? First we integrated PyangBind in the environment itself so that test can pass using PyangBind. So I created a bash script which downloads the yang file corresponding for the Jenkins test branch and generates PyangBind Python classes in the directory. So yeah, bash script, what it does, it uses the it uses PyangBind to generate binding files, and those binding files are Python high level representation, so that we can use those bindings in the test file itself. So this script will create a folder inside the workspace directory which will have some Python classes that can be used by our builder code. So yeah, so once we have those binding files present in a folder, we can use them in our JSON generator library. So I created a library JSON generator. It has like many Python helper functions that can return the expected JSON for the tests. So what we'll do, we can now call these Python helper function and give them some sensible defaults to get some JSON back. So also then we created some robot keywords using Python library to make the Lisp test more readable and high level. Yeah, so there were some cases where we need to do the same thing in different tests again and again. So we kind of make it much more modular and make some keywords so that the tests are more readable and high level. So, and finally we migrated the test to use our new framework. So it's like the final output that was the final deliverable of my internship project. So previously the tests were like they were using the files itself. So you can see in the left side, in the red, they are directly using the manually written JSON files. But here on the right side, they are using the keywords itself. So it is much more readable, and also it is not consuming any space, because there we had like around 40 to 50 JSON files already present in a Beryllium folder. So that's not a good thing. So here we are directly generating the JSON on the fly. So as you can see in the first example, on the left side I couldn't say what are the arguments, what is EID, so it is not that readable. Here I can exactly see and say that this is using the IPv4 EID. So this is kind of a demo. I can also show a little demo of how to generate the binding files using PyangBind. So our bash script, it takes two parameters. One is branch, and other is workspace. now if I run my generate underscore binding bash script, so it will create the binding files. Sorry. So it should be capital. Yeah, so here we are downloading all the corresponding Yang files for the list flow mapping MSMR robot tests. Yeah, so it says like Yang dependencies and bindings downloaded successfully. That means that PyYangBind had generated all the Yang bindings for the corresponding robot tests. So as you can see, there is a folder that is ODL list flow mapping Yang files. So it holds all those PyYangBind generated Yang bindings. So yeah, there is a folder list flow mapping Yang bindings. Now so this is JSON generator library that had all the Python helper functions that we can use in any robot test. So like at the end I'll show you that I'm now using the get lisp address JSON keyword. It will take some parameter and return the JSON. So this is just for the demo. In the main code base these debugging statements were not present. So yeah, so this JSON generator library used all those generated Yang bindings and now creating this JSON on the fly. So this is how we can like migrate our test. Instead of using all the manually written JSON files, we can use these helper functions to directly generate JSON on the fly and then check if it passes or not. Yeah. Thank you. That's all from my side. Thank you very much.